You'll be expected to know how to calculate perimeters given different geometric shapes. I'll review this skill with you now in the classroom. Okay, now let's talk about finding perimeters. A couple easy ones. First one could be a square. I'm going to draw it. And you have all the same side length. All the sides are the same. Let me call one the side length x's just to put a variable, because you might have to put the perimeter in a variable expression. You never know. So if I'm going to let P equal perimeter, it would just be the sum of all sides. Don't forget, when perimeter, we're talking about distance around an object. It could be sum of the sides if all the sides are straight, or we'll get into something when they're round like a circle. Perimeter would just be 4 times x, because if you, which is the same thing as adding x plus x plus x plus x. You got 4 x's. That's a quick way to do it if you needed to. Let's see the second one. Rectangle. See, we call this the length, and we call this the width. The perimeter is this going to be 2 lengths, because if this is a length, this is going to be the same. The side opposite is going to be the same. That's just dealing with definition what a rectangle is. Opposite sides are the same length. So you would have 2 lengths plus 2 widths. Or what I like to do, I just like to add the length and width and double it. It's kind of like you factor it out of 2. All right, the third one, which a lot of people always have a tendency to mess up the formulas, and that's talking about perimeter of a circle with a given radius. That means the distance from the center to the outside of the circle. They call that circumference. It's given a special name. So it's like distance around, like taking a lap, if you will. 2 formulas you need to know. 2 times pi times r, 2 pi r, or you can find circumference if you know the diameter, because you know diameter is equal to 2 radiuses. That's kind of like if you took this radius and you extend it out, you have another radius, you have one here, so that would give you 2 r's, or a diameter. So you can call it pi times diameter would be another way to find the circumference, or the perimeter around a circle. Okay, now let's take a look at some specific situations where you're going to have to think a little bit on how you're defining the perimeter, distance around an object. You're probably going to maybe even have to use a little bit of Pythagorean theorem. I'm going to give you a square. So you know all the side lengths are the same and the sides meet at 90 degrees. What if I was to draw a diagonal in there? And let me label some vertices here now. Let me call this one A, B, and I'll call this one C and D here. And say you were asked to find the perimeter of triangle ABD. And they gave you the side of one side of the square. Say I tell you it's 4 inches. We'll call this 4 inches. And you had to find the perimeter of ABD. Well, first of all, you have to know that we got a right angle here at A. And you can look at it. Now, just draw the triangle and try and just look at the one part, just the triangle that you're looking at. So we have A, B, we got D here. We know that this length here, AB, has to be 4, because you're told the length of one side of the square. That means AD also has to be 4 for the same reason. Now to find the perimeter of this triangle, you're going to need the length of BD. You can use Pythagorean theorem, or if you know a little bit of things about, if that's a square here, we have right angle, this angle here, angle D, and this angle B here have to be the same. Why? We have a right isosceles triangle. And I'm going to show this way. You can use Pythagorean theorem. I'm going to show you a quicker way, I think. Since you know that these angles are congruent, that means that each one has to be 45 degrees. Because if you add 45 and 45 and 90, you get 180. That's just a real quick proof to you. But if you remember your 45, 45, 90 relationship, it goes x, x, x radical 2. And you just have to look at what you were given. You were given the side opposite of 45, a length of 4. So opposite the other one, 45 has got to be 4. And then the length opposite The 90, you can plug that x equals 4 in, so you know we're going to have 4 radical 2. So we can write this really quick, 4 radical 2. You just have to know your 45, 45, 90 relationship. So the perimeter now is just going to be, you add the sides up. You're going to have 4 plus 4 plus 4 radical 2. Now you can only add, don't forget, when we're talking about adding radicals together, you have to add like terms. Those guys, that's going to give you 8 plus 4 radical 2. Now, depending on what kind of answer they give you, you're just going to have to be careful of whether to put it into decimals or not. I'll probably leave it like that, but you can easily put that in your calculator to convert it to decimals if you need to. All right, let's take a look at another example. Now I'm going to give you a square, but we're going to put in a circle inside it. We're going to inscribe a circle in a square. So let me go ahead and draw a circle. And we're going to draw a square. Believe it or not, that's a square. And I'm going to put a radius in there, and I'm going to label these sides, or these vertices, A, B, C, and D. And I'm going to give you the length of this square. I'm going to tell you the length of one side is 6, let's use centimeters. And you're going to be asked to find the circumference of this circle. If you are asked to find the circumference of this circle, well, that would be the distance around the circle. Now remember, there's two ways to find circumference. Pi times diameter, or 2 times pi times the radius. Well, you're given the length of this square. Well, that would actually have to be the diameter of this circle. So you're told that the diameter is 6 centimeters. So you're probably going to want to use the first equation I wrote here. Circumference equals pi times diameter. So circumference is going to be 6 times pi. And the units will be centimeters. Now they might give you 6 pi as an answer. You might have to take 6 and multiply it times 3.14, or use your pi key on your calculator. I'm going to give you a trapezoid now. A very specific trapezoid. Let me label A, B, C, and D. Isosceles trapezoid means you have a quadrilateral with one pair of parallel sides. Those sides are going to be A, B, and DC respectively. But these guys, AD and BC, would have the same length. Let me give you some distances. Say I tell you that AB is 12 inches. And I'm going to tell you that DC is 18. And I'm going to give you a height of this trapezoid now. So I'm going to draw a dotted line in there, and not a very straight dotted line. I'm going to give you that height, and we'll call it 4 inches. And you're asked to find the perimeter of this trapezoid. So that means the distance around from A, B, to C, to D, to A. So the problem is we have a distance of AB and DC, but we don't have the distance of the congruent sides, AD and BC. You need that length. Well, what we can do is we can also do the same thing I did over here, draw another right triangle. And we know this is a distance of 4 for the height. Now let's think about what is the distance from here to here. Well, that would have to be 12 because we just created a rectangle in there. And if you have, this is a distance of 12, how much do we have to add to 12 to get the total distance of the base of this trapezoid, which is 18? You would have 6 more inches left over. So these guys got to be the same distance, so this has to be 3 inches here and 3 inches here. Oh, what do you notice? We have a right triangle here. We have a right triangle with a base of 3 and a height of 4. You could use the Pythagorean theorem to find this distance. And then this guy would have to be the same. So let me show you Pythagorean theorem now. We got 3 squared plus 4 squared is going to be equal to this segment. We'll call it AD squared. So you're going to have 9 plus 16 equals AD squared. To solve for AD, because you need the length of AD, not AD squared, you're going to have to take the square root of this sum, So that sum is 25, so you're going to get square root of 25 is equal to AD. So AD has to be 5. So I'm going to write it in here so I can see it, 5 inches there. And we know that since AD is congruent to BC, that's going to be 5 inches also. All right, now we're finally ready to find the perimeter. So perimeter might, you think, don't want you to overlook it because you think, oh, it's easy. This is a little bit more complicated, a lot more involved. You've got to know a lot more besides just adding all the sides because they're not always going to give you the lengths that you needed. So let's just start by going around the top. We'll take that distance, which is 12, then 5, then 18, and then 5. And if you add those up, well, let's see. Here's what I do. I kind of just do it real quick in my head. We're adding the 12 and the 18. That will be, what, 20 and 8, and 2, so that's 30 there. Then we have the 2 5s. That's 10. Of course, you got your calculator. I'm just trying to show you how you could do it without a calculator if you need to. So you're going to end up with 40 inches. Perimeter, don't forget, is always measured in a unit, a single unit, not units squared, not centimeters squared, inches squared, feet squared. That's area, and we're going to talk about that next.